Okay, question 14. A large spherical balloon is deflating. At time t seconds, the balloon has radius r centimeter and the volume v centimeter cube. The volume of the balloon is modeled as decreasing at a constant rate. So the volume of the balloon is modeled as decreasing at a constant rate. So that means dv over dt. So the rate of change of volume by time is equal to, so decreasing means negative. And then a constant rate, so we can just use constant number. So like use a random letter to represent it. So I will use just a to represent it. And then using this model, show that di over dt equal to negative k over r squared, where k is just a positive constant. So to set this up, we want dr over dt. So that means like we don't have enough information straight away to find it. So it has to be something to do with a chain rule. So if it's chain rule, it has to be start from dr and then over something times by something over dt. So the only thing can link them is v, because we already have dv over dt. So it has to be dv over dt, and this is di over dv. So we already know what dv over dt is. So the only thing we need to find is just dr over dv. So it's a spherical balloon. So that means the volume of a balloon is just volume of the sphere is just v is equal to 4 over 3 pi r cubed. So then dv over dr is just equal to, so bring down the power, 3 times 4 over 3 is just 4, and then minus 1 the power, so that would be r squared. So that means dr over dv is just the reciprocal of that, 1 over 4 pi r squared. So now if we substitute everything in, so we have dr over dt is equal to dr over dv, which we already know, 1 over 4 pi r squared. And then times by dv over dt, which we already know, that's just negative a, and a is just a positive constant. So then that will be negative a over 4 pi r squared. And then because a is a positive constant, the 4 pi is also a positive constant. Constant over constant, let's just give us another positive constant, which we can use k to represent it. So that would be negative k over r squared. Okay, part A done, 3 marks. And then part B. So part B, they just gave us some conditions here, and then they want us to solve that differential equation to find an equation linking R and T. So we have dr over dt equal to negative k over r squared. So we need to move all the r to one side and all the t to one side. So our times by r squared for both sides, and then times by dt for both sides. So we can take integral for both sides. So integrate r squared, that's just r cubed over 3 plus 1 the power divided by the power. And then negative k will integrate to negative kt plus c. So, and then we can just substitute the conditions. So the initial radius of the balloon is 40 centimeter. So that means when t equal to 0, r is equal to 40. So substitute in 40 cubed over 3 is equal to 0 times anything is equal to 0. So that's just what c is. So put in 40 cubed divided by 3. That's 64,000 over 3. So we have our equation to be r cubed over 3 equal to negative kt, and then plus 64,000 over 3. And then the second condition says after 5 seconds, the radius is 20. So that means when t equal to 5, r is equal to 20. So substitute that in. 20 cubed over 3 is equal to negative k times 5 is just negative 5k plus 64,000 divided by 3. So then 20 cubed over 3 minus 64,000 over 3. That's just negative 56,000 over 3 equal to negative 5k. So the negative cancels out. So k is equal to 56,000 over 3 divided by 5, which is 11200 over 3. So now we have the equation to be r cubed over 3 equal to negative 11200 over 3t plus 64,000 over 3. Simplify that, r times by 3 for both sides. So r cubed equal to negative 11200t plus 64,000. And then r is just equal to cube root of, I can write as 64,000 minus 11200t. Or you can just cube root of all that like before. It's fine, both works. And then for part C, find the limitation on the values of t for which the equation in B is valid. So of course, time has to be positive, so does the radius. Yeah, so you can't have negative radius. So therefore, whatever inside the cube root has to be positive. So then 64,000 minus 11200t has to be more than 0. So then 64,000 is greater than, so our plus 11,200t for both sides. So then 64,000 is more than 11,200t. So divide by 11,200 for both sides. So 64,000 divided by 11200. So we have 40 over 7. So that means t has to be more than 0 and then less than 40 over 7. Then that will be the final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.